recalled. Okay, so here we are having these different types of faults: functional fault and system fault. Okay, this is functional faults means related to your field instruments. System fault means related to your CPU and IO modules. For this, if there are OBs, error OBs are present, the CPU remains in run mode. If it is not available, it goes to stop mode. Okay, just I am repeating. These are the methods to check the errors in software and on the hardware modules also. Whereas for instruments, we have to check on the module, as well as you can go online and you can check that in the program block as well as in the variable table or watch table in TIA portal. Okay. Then we are having different OBs. So these OB types, okay, are having some event numbers. Okay, they are having some OB numbers and event numbers. What is event number? Event means what? If anything is happening, like that is some event. Like there might be some error which might occur anytime. Okay, there is also one type of event. Similarly, if you are executing any program for every milliseconds or in terms of seconds, okay, like your CPU is scanning your program in milliseconds, but I don't want to scan the program in milliseconds. I want to scan every seconds, okay, like 5 seconds, every 10 seconds, like that. Only one time, every 5 seconds, one time it should scan, means only one time it should execute. So like that, these blocks can be executed. So first block is OB1, which is also known as cyclic execution of user program, and its event number is 1. Okay. Similarly, time dependent interrupts. Time dependent means it depends depending on the time. It depends on the time, like date and time, or every milliseconds or seconds. Okay, depending on the time. So there are different OB types we are having. One group is time of day interrupt. Interrupt means here it is holding your program, stopping your main program, which is in OB1. It is stopping your main OB program. So these OBs are ranging between OB number 10 to OB number 17 only, and they are having the event number 2. Another OBs groups are cyclic interrupt OB. Cyclic interrupt means continuously. Cyclic means continuous. Okay, continuously it should interrupt for every milliseconds. Okay, or every second or minute or hour. Okay, that way also you can select. Okay, so time of day means at some particular date and time or on some particular day you should start and interrupt the program. Okay, depending on the date and time also you can execute. Okay, these OBs. So cyclic interrupt is starting from OB number 30 to 38, and they are having numbers from 7 to some like 15. Similarly, we have time delay interrupts. Time delay interrupt means if there is any error, I want to generate some delay. Okay, for that you can use time delay interrupt blocks. These OBs are ranging between OB number 20 to 23, but these options are generally available for S7-1200 series for high-end controllers. Okay, where we are using large number of analog signals. Okay, for those analog signals, if any signal is not coming, okay, so in such case we are interrupting your program. Okay, so S7-1200, which is a high-end controller, means which can handle large number of inputs and outputs. Okay, so generally that is used for one second. Generally that is used for handling large number of analog IOs, because this high-end controller is having faster scan cycle compared to 300 system. Okay, so here the event numbers are 3 to 6. So here higher the event number, high error preference. Means it will compare between event number 1 and 15. So which is higher number? 15. So it will stop your OB1, execute this only one time, and then go back to OB1. Okay. Then if any other event, any other block, like OB number 10 you are using, so its event number is 2. So when this particular date and time, okay, like Monday, uh, at some time like 9 a.m., some motor should be on. So when that particular day and that date or time occurs, okay, it checks with this OB1 and OB10 event number. So OB10 event number is higher, number 2. So it stop OB1, execute this only one time, and then go back to OB1. So this is what is happening here in the OBs. Okay. Now other OBs apart from OB1 are executed only one time when that event occurs. Whereas OB1 is scanned continuously. Okay. Then other OBs are known as error or fault OBs. These are hardware interrupt, and these are ranging between 40 to 47. So in analog, generally it is used. Okay. So you can set the range, like if I want only 0 to 10 volts. If it is crossing 10 volts supply, means I said no, will not be exactly 10 volts. It will be exceeding 10 volts signal also. There will be some fluctuation. Okay. If it is exceeding that range, then it should show some error. Okay, so interrupt your CPU. But I don't want to stop the CPU. In such case, I can download only OP number 40. Okay, the CPU does not go to stop mode. Okay, so like this, it will show the error. Similarly, we are having synchronous and asynchronous types of errors. Synchronous errors are known as programming errors and IOSS error. These OBs are OB number 121 and 122. Programming error means like we are creating some FCs and FBs. Suppose if I am creating some FC and I am calling that in OB1, but I forgot to download FC. Okay, so what happens? Your CPU searches for that particular FC, right? If it does not find that FC, it goes to stop because there is a fault, okay, or error in the program. Okay, so CPU goes to stop mode, but it should not go to stop mode. In such case, we have to download OB number 121 directly without any logic also you can download. Similarly for IOSS error, if you are giving wrong addressing, okay, wrong addressing means like if there is a 64 for analog address, okay, byte number 64, but you are giving some any other address like 80 or something, which is not available on the module. So what happens? It cannot read the address. Okay, it cannot read any data from that address because it does not find that address. So your CPU goes to stop mode. Okay, it should not go to stop mode if such error occurs. You have to download OB number 122 for that. Similarly, we are having asynchronous errors which are ranging between 82 OB 87, and these are having event numbers 26 to 28. Asynchronous errors which might occur anytime. Synchronous errors which are occurring like when you are doing any programming or downloading some blocks, okay, they're modifying, okay, at such time it will occur, or you are giving any wrong addressing, okay, that is during programming, right? So these errors occurs during programming. But asynchronous errors which occurs anytime, like depending on the time error, execution time, if it is taking more execution time, okay, then means like there is a limit like 150 milliseconds maximum your CPU can take. But if it is crossing that limit also, for example, within 5 minutes I should uh, means complete 1 kilometer distance within 5 minutes. Okay, but if I'm exceeding the time, right, so that is an error. So like that, we're having some time error for scanning your program. Okay, if I'm having some limit, how much time it should take to execute any program. If it is exceeding the time, it goes to stop mode. But your CPU should not go to stop mode, then download this OB number 80. So like that, for different types of errors which might occur anytime, we're having different OB number blocks. So these blocks we can download according to the logic. If you are using remote IOs, for that we have to download OB number 86 and 85 because it cannot read that particular address, and if there is a disconnection of your Profibus or Profinet, it cannot read the data as well as there is a disconnection. Okay, for that we have to download both the blocks. Okay, so here for S7-1200 also we are having special blocks OB number 83 and 84. If you are removing any module, input or output module for replacing, okay, in between the program also, it should not go to stop. For that we have to download these blocks. Like this we are having these different blocks. Similarly we have restart blocks. Restart blocks like whenever we are starting our laptop, what we are doing, we are right clicking and refreshing. Right click and refresh. That means we are resetting your memory, right? So similarly here, these blocks are working in such format, means these blocks are executed initially, but we cannot use all the blocks here. We are having only three blocks. One is warm restart, hot restart, and cold restart. So these numbers are OB100, 101, and 102, and they are having event number 28. Sorry, 27. Okay, so these blocks, out of these three, you can use any one block. So generally we use warm restart block in the beginning. So warm restart means it refreshes your memory. Okay, it does not reset return to memory. Return to means which retains, which holds previous value. Okay, it does not reset that memory, but it reset RAM memory, which is non-retentive. Okay, which is resetting to zero. Okay, those memories are RAM memories reset to zero, whereas ROM memory is not resetting to zero. It is just refreshing it. Okay, whereas hot restart is like refreshing, only refresh. Okay, refreshing the memory. Sometimes what happens in some memory, if you are storing some data, that will not be erased. Okay, it will be retaining, but it should refresh and it should reset to zero. It should refresh the memory. For that we can use hot restart. Cold restart, I want to reset all the memory, RAM as well as ROM memory in the PLC. I want to reset all the data from beginning. I want to execute. For that we are using cold restart. Okay, you can do this manually or you can do it through program also. Okay, so we are having these different OB numbers which you can use in your program. Okay, so these blocks are not only for 300 or 400, even for your 1200 and 1500 controllers we can use. Okay, so they are just upgraded some software and display. We are seeing that display right already. uh, all the windows are configured in a single window, whereas in the older software like in Semantic Manager, hardware configuration purpose separate window you have to open from the main window. For program block you have to open from the main window. Like this you have to open these blocks from main window. Okay, so it takes more time. So what Siemens has done is they have configured all the windows in the same picture. Okay, from left pane or right pane windows you can directly open and close those options, or you can create the blocks there only. Okay, there are many advantages they are added, and some instructions also they are added. Okay, advanced instruction they are added. Here you can see what is happening in the cold restart, warm restart, and hot restart. It is cold restart is resetting the total memory, RAM and ROM memory. Okay, retentive and non-retentive. Non-retentive means RAM memory, retentive means ROM memory. Hot restart is just refreshing the memory. Okay, warm restart is also refreshing and resetting RAM memory, but it is not resetting ROM memory. Okay, cold restart is resetting both. Okay, reset means 0. Okay, so this is what is happening in the diagnostics. So in TIA portal, to check your diagnostics, okay, if there is any error or fault, okay, like I create one block here, so like FC I am creating, say okay. So where is that block? FC number block 1, FC number 3. Drag and drop. I am not writing any program, so I simply open OB1 and I call this FC3 here. Sorry. Writing logic in FC3 is different thing, but I'm just calling this in OB1 and I'm downloading only, selecting only main block. For that I need to start the online simulator first. Load, finish. Okay, block 1 was loaded successfully. It has loaded that block also. So now this is in run mode. Okay, what I do, I again create one more FC, like block 2. Then in OB1 I just call this block 2. Anywhere I can call. Now I select only main OB1 and download. Okay, so here you can see block 2 was loaded successfully. Main block was loaded successfully. So here that thing means generating that error is removed. Means even if I download the program, it is downloading all the blocks available here. In Semantic Manager, what happens is if I select only OP1, it is downloading only OP1. It's not downloading FC. Means we are missing that block. Okay. But here in this case, it is not allowing. Means it is download selecting all the blocks and downloading. Okay. So that's a good thing they are given here. So there is less chances of getting such errors. But in case if you get any error, you can check the error in this PLC1 is our PLC, right? In that you can see online and diagnostics option. When you double click on this, it opens one more window. So this window will appear. Here you can see diagnostics option. Diagnostics, okay, it is not connected, so I select this and we go online with this. Okay, we have to select our connection PNIE, which we are doing in the beginning, right? Just go online with the CPU. Now it is online. Okay, it is showing the connection. Now, then you go to the diagnostics. In this, where I am diagnostics buffer. Diagnostics buffer is the location file where you can find the CPU status or any error or faults. Okay, will be displayed here in the list. Okay, and If you select any error here like this, at the bottom you can see it will show the details on that event of that error. Okay, what is the error, issue, problem, what you have to do, remedy, that also you can see. And diagnostic status, module exists and okay, because on simulator we cannot see much things here with the hardware, so only we can work properly. Functions, set time. Okay, set time means it will set the present date and time of our QC. Okay, you can apply that. Or if you select reset to factory setting, means when the product was made, that PLC was manufactured and updated with the internal software. Okay, so those settings will be shown here. Okay, reset to factory settings. Then if you want to see some general properties, this is about the CPU information only, memory, how much memory your CPU is having, load memory, work memory, and the retentive memory. How much retentive memory is available? Okay, that it is showing here. Okay, so it is like around 4 MB, I think. Okay, internal memory is already, load memory is provided as 4 MB. Work memory it is using around, it is in bits or bytes, I think. 500 KB maximum. 512 KB will be there. Okay, see 512 KB. So like that, it is showing you the cycle time, how much scan time it is using to execute the program. Okay, that also you can see online access communication. Okay, so this is about the diagnostics, and you don't have much options here. See here also you can check. Hmm. Hmm. Okay, so this is about the diagnostics here. It has not given much options here. There is to be a lot of things in TI, this semantic manager, but in TI portal it is not having much things. Like some options was there. Show reference text. Listen, not showing anything. Here only. Okay. So